So Docker is this fantastic technology that emerged in the Linux world. It spent 3 years evolving and maturing in Linux, and then at the end of last year, it landed in Windows Server, fully featured, fully fledged, ready to go. Docker doesn't care about what sort of applications you run, but today I'm going to focus on traditional .NET apps. By that I mean old applications. The sample app I'm going to use is an ASP.NET Web Forms app, and what I'm going to be talking about today is, to start with, an overview of the Docker platform. So for those of you who aren't familiar with it, very quickly run through the major features. It does a huge amount of stuff. I'm going to focus on the main workflow for bringing your apps into Docker and what that does for you. Then I'm going to take my Web Forms application. I'm going to get it running in Docker and show you what you need to do to make your app run in Docker without any code changes. You can take it as is, run it in the new platform. And then I'm going to use that as the jumping off point to modernize that application, add new features, new capabilities, quickly and safely by leveraging what we get from Docker. I'm not going to talk about microservices, DevOps, the cloud, .NET Core, Nano Server, or Linux. So, big list of technologies and approaches which are all excellent, and actually Docker fits in really nicely if those things are on your radar. But the sort of apps I'm talking about are the millions of user-facing apps that are running all around the world that probably are not going to fall into this space, because to take any of these new trending technologies, new approaches, is a re-architecture job. It needs a lot of investment to take your app and bring it into this world. But by using Docker, you can get a lot of the advantages without having to do a full re-architecture. So I'm going to start with my really simple, basic, frankly, rubbish demo application, which runs on my laptop to start with. It's a Web Forms app and a SQL Server database, and they run natively on the laptop. And the first thing I'm going to do is port them so they run in Docker. So I've got one container for my web application and another container for my SQL Server database, and Docker takes care of the plumbing to make sure all the components can talk to each other. So there are advantages in just doing that, but that's my starting off point to then iterate over my application. And through the rest of the session, I'm going to be adding more features until we get to version 5, which is a fully distributed solution. It looks like a gratuitous jumble of containers, but every single one of these components is there for a reason. And the modernization approach that I'm taking is feature-driven. So I'm adding features to my application quickly and easily by using Docker. Okay, so the starting point. So Docker is a platform for packaging, distributing, running, and managing applications, any kind of application, as long as it doesn't have a UI. We're talking about server-side applications here, websites, web services, console applications that run on a schedule or anything like that. So in the Windows world, it runs natively on Server 2016 and Windows 10, and it runs in the background as a Windows service. So if you're moving your apps to Docker, what you have running on your VM or your bare metal server is just Docker. You don't install the .NET framework, you don't install IIS, you don't install anything else. This is bare minimum. All you need is Docker to be running, and everything else is going to be running by Docker. So to make your app run in Docker, the first thing you need to do is package it up. That's part of the platform, the notion of being able to take a whole bunch of different components and package them into one unit. So for an ASP.NET application, the way you do that is by building up a script that describes all the steps you need to take to package the app. So I'm going to start with Windows Server Core because I've got an ASP.NET application. That's just going to give me the full Windows Server features. Then I install IIS, install .NET, install ASP.NET, and that's going to give me my kind of basic hosting environment. Then I copy in my own web application with whatever dependencies it's got, and then I need to configure it all so it all runs and it's all set up and ready to go. So in the Docker world, you capture all those steps in a really simple script file called a Docker file, which we'll be seeing shortly. And then when you're ready to package your application, you run a command like docker build, and Docker goes through all of those steps, runs any commands you need to run, copies any files you need to copy. And the output is a single binary, logically a single binary, which contains your entire application stack. The whole thing, your app, all its dependencies, the runtime environment, even the version of Windows that you need to run it on, is all packaged into one unit. Okay, and that Docker file is really simple. So there are a few new instructions to learn, but actually it's a really simple way to take an existing application and run it in the new platform. So we'll see more of this during the session, but if you've never seen a Docker file before, hands up if you've never seen a Docker file before? Cool. So even if you've never seen it, it's fairly straightforward. There's only about half a dozen instructions you need to learn. And so we'll go through this one by one. We start with Microsoft Windows Server Core. So what that's saying is this is my base. This is another Docker image that I'm going to use as the starting point for my image. This happens to be Windows Server Core, which is a clean, up-to-date installation of Windows Server 2016 without the UI, which is owned by Microsoft and managed by Microsoft. It's publicly available. So when I build this image, the first thing Docker will do is start with that image. So I get everything that's already been built by Microsoft. Next command is just a bit of boilerplate to tell Docker that from now on, in this Docker file, I'm using PowerShell for my instructions. And then I start building up my application. So I run some PowerShell to add the Windows features that I need, so IIS and the ASP.NET and the .NET framework. And I remove the default website because I don't need the default website. Then I copy in my published web application. So in a CI pipeline, my build has already run. I've generated the published web app with all the binaries and all the content before I do this step. And this is the packaging step that copies in my web app into my image. And then another bit of PowerShell to set up my web application. So I know exactly where it is. I know the physical path because I've just copied it in. So I know where my application is going to reside. So I create a new website, and I specify it's going to be on port 80. Now, when I run this application in Docker, by default, the container is locked down. You're not allowed to communicate with it from the outside world. You have to explicitly enable that. So the next command, expose, it's like a really basic firewall. It says, this application is allowed traffic to come in on port 80. And the final thing is we tell Docker what to do to start my application. So when I run my application using Docker, it's going to, the entry point is telling it what command to run to start everything up, which is just a basic script that's going to start IIS and make sure that it keeps on running. So we'll spend more time with this, but this is all you need to do to take an existing web application and move it into Docker. So when I've got my Docker file, I've run it through the Docker build command. The output is my image, so that's a single thing. That's probably on my laptop or on my build server, and I need to be able to put it somewhere else so that I can run it on my test environment or my production environment. So the notion of distribution is built into the platform. So when I've got my image on my build server or my laptop, I can run Docker push and push that image up to a central location. Docker calls that a registry. Now, that registry could be a private registry in my data center that is only for my company to use, or it could be a public registry, and Docker have their own public registry called Docker Hub. The fact that you can share software publicly, if it's open source software, is a massive enabler to start bringing tried and trusted enterprise-grade components into your own solution, which is what I'll be doing today. So Docker Hub is one of the reasons why Docker has taken off so much in the Linux world. So at the end of last year, there are 500,000 images on Docker Hub, 500,000 packaged applications that you can bring down and run. Most of them are Linux, but the number of Windows ones is increasing. And it's absolutely taken off. So as of last year, there were 8 billion downloads of these images. And you think about these images are a packaged application, that means 8 billion times someone's downloaded those applications and got them running in their own environment without having to do any other setup work. We're currently running at about 1 billion downloads a month. So it's pretty popular stuff. So when you've shared it and you're ready to run your application, that's all built into the platform too. So you do a Docker run command, you give it the name of the image that you want to run, and because it's all built into the platform, the notion of images and registries, if the image isn't available locally, Docker will go off to the registry and pull it down for you, and then it runs that application from the image in a container. And a container is just a really lightweight boundary around the processes that are running inside your application. So in the case of a full .NET framework app running on Windows Server, we'll see the processes later, it's going to be the worker process, the W3 process that's hosting my application. So I've got my W3 process running on the host with all the supporting processes it needs, with a boundary around it to isolate it from anything else that's running on that machine. It's not like a VM where I have to allocate CPU and allocate memory. It's just a process running on my machine, and I can run as many as I can, as my machine can handle. So not only is it really lightweight, it's also portable. So I can run the exact same Docker run command on my laptop, and I'll get exactly the same application. The whole thing's configured and ready to go, so it'll behave in exactly the same way, no matter where I run it. If I spin up a VM in the cloud, like I said I wasn't going to mention, then it'll run in the same way too. OK, so that's the basic workflow that you get with Docker. Those are the basic features of the platform. You can build, ship, and run any type of application, and it'll be the same no matter what environment you run it in. So now we're going to cut to the demo. So my demo application, it's like a marketing website for a new product launch. So we're going to step into that now and see version 1, which is running natively on my laptop. OK, so let's fire this up. So I don't want to get your hopes up. It's rubbish, but the point is the code's all up on GitHub right now, so you can check this out and you can follow along with me to see what I'm doing. So this is running on IIS on my laptop. There's a little launch page, and there's a big button to sign up to say, I'm interested in your product. Here are my details. Let's click that properly. And please send me some emails. So I've got SQL Server on my laptop. I've got IIS on my laptop. I've got .NET installed. If I want to run this on a new environment, if I commission a new test environment, I need to install IIS. I need to install .NET Framework, the right version. I need to have access to a SQL Server and all that stuff. And that's probably going to be in a big, complicated deployment document with loads of screenshots that's totally out of date and never updated. So it's not a great position to be in. So what we're going to do is move this to Docker. That's going to be our first point of call. So what I've done, because I'm trying to do 5 versions of this app, I'm not going to live code. I've got it all checked in already in different Git branches. So you can follow along with this yourself and check out version 2. And I'll go back to my product launch website and show you what I've got here. So the code for this is really basic. I've got Entity Framework, which I'm using for storage to talk to SQL Server. I've got the main entity is this prospect, which contains all the details that you put into the sign-up form. It's just an ordinary, plain old object that contains these various details. And then my web forms application has got the main page is this sign-up page. There's a whole bunch of boilerplate stuff, which is not going to change throughout the session. But the interesting stuff is when you click the Go button. So when you click the Go button, it does exactly what you'd expect. It spins up a new prospect object, copies in the data from the web form, and then it uses Entity Framework to make a connection to SQL Server. It looks up the dependent entities, the country that you select from the dropdown and your role, and then it adds it to the prospect collection and saves the changes. So as of version 1, this is a synchronous connection to SQL Server. It's actually going to make 3 queries to look up the details and save my new entity. And this is how we're going to use it in Docker. The only thing that's actually changed between version 1 and version 2 is a configuration setting. So version 1, I'm using SQL Server on my machine. This is version 2 now. The only change is the host name for the server, because I'm going to be running SQL Server in Docker. Now, part of the Docker platform, it has a built-in DNS server. So when I can talk to containers, I can talk to them by their container name. So when this application is running in one Docker container, and I say I need to talk to SQL Server on a machine called SQL Server, that request goes to the DNS lookup goes to Docker. Docker finds there's a container running on this machine or a different machine in the same Docker cluster, and it will route the traffic appropriately. So the only change is a configuration change to say I'm going to run, this is the name of my host, which Docker is going to resolve to a container for me. OK, so I'm going to reset my environment to get rid of version 1 and start building this, and we'll look at the other pieces now. OK, so as well as the full Visual Studio solution, I've got some assets that are in a Docker folder, which is how I'm going to actually package this thing up and run it in Docker. So for my website, I've got my Docker file, which is broadly the same as the one that we saw earlier. So I'm starting from Windows Server Core, so that's going to give me my clean installation of Windows. I'm switching to PowerShell, so from now on I can run commands in PowerShell. And then I have to do a bit of a hack to turn off the DNS cache in Windows. Because Docker's got its own DNS server, it expects you to always ask it for addresses so that it can resolve it to the correct container running on the correct machine. And Windows is a bit too aggressive with the way it caches DNS responses. So just a simple bit of registry hack to turn off the DNS cache. Then I install IIS and ASP.NET, and then I remove the default website because I'm only going to have one application in this container. I could have several websites in my Docker image, but that's not really what Docker's about. Docker's about having one container per application, so I can scale independently and release independently and do all that sort of stuff. So then I copy in my built website, my published website, into the image, and I run new website to set that up in IIS. Again, I know exactly where it is, so I've just put it there, and I'm using port 80 to listen for traffic. I expose port 80 so traffic can get into my container, and then I need to tell Docker how to start my application. And this service monitor app is a little exe from Microsoft that they ship with some of their images, which starts a Windows service for me. In this case, it's the IIS service, and it will monitor it and check that it's up and running. So when Docker starts an application, it watches the process that it started, and if it fails, it will flag up to the platform that a container's gone down. So what this little helper app does is it just makes that flag possible. So if there's a problem inside the container and IIS stops responding, this will bubble that up to Docker. So in terms of a kind of CI process, this is my CI, this build script here. I've got I'm using MS Build to publish my website. So I'm running that from my Visual Studio solution to publish that web application. And then I run Docker build, which is going to go through my Docker file and package up all those different components. OK, so that build will have completed now. So if I run back through my build script, I've got all the output from MS Build, packaging and moving everything around. And this is the output from Docker. So when I run Docker build, each of the steps in my Docker file gives me some output. Docker tells me what it's doing. Now, I said that Docker images are one binary file, which isn't true. Logically, they're one thing. So I refer to a Docker image by one name, and I get my one image. But physically, they're layered. They're split into separate layers. And those layers can be reused. So what's happened here when I've built this application, Docker said that I've already got a layer that's the same as you've asked me to build, so I'm just going to use that. So it's a really efficient way of having lots of applications that share a lot of common features. They would share the same layers. So you don't use up a lot of storage here because all the big base layers that have got Windows and IIS would get reused throughout all your applications. And then at the end, I've got my new image, and it's going to be ready to go. But it needs a database. So what I will do is go to my cheat sheet to make sure I run the right command, and I will start SQL Server running on my machine in a container. OK, so what this does is it's the docker run command that I mentioned earlier. And docker run, let's get rid of that because that doesn't look good. So I'm docker running a new container. The D flag means detached, so it puts it in the background. So long-running service is a database, so it's going to keep running in the background. And P is exposing a port so that I can get into SQL Server. The image name is this, so that's the image. That's also on Docker Hub. So that's SQL Server Express running in Windows, which is owned by Microsoft and is publicly available on the hub. SQL Server Express is free. There are certain limitations, but actually they're not very severe. And it's a perfectly good and usable relational database. So I can pull that from the hub, and I can be using that. I've given it a name. Oh, let's go back to that. So I've given my container a name, SQL Server. That's how the other containers are going to find it. And I'm also specifying some environment variables. So I've got an environment variable to accept the license agreement and to specify a password for the admin user. So if you think that having that password in plain text is bad, you're absolutely right. And there are much better ways of doing that in Docker. But to get through 5 versions of my application, I'm doing it the quickest way possible. So what the E flag is doing is passing a value for an environment variable to the application. And in this case, it's SQL Server. And when it starts up, it's going to pull that value out of the environment variable and set up the SA user to have that as their password. OK, so if I look at what's running in Docker, Docker PS just tells me all the containers that are running. I've got one container now. It's running from SQL Server. It's got a random container ID, but it's also got a name because I gave it a particular name. So now effectively that's my database set up and ready to run now. And so now I can run my application. So Docker run -d. It's a web server. It's going to be long running, so I'll put it in the background. -p to make that port available, so port 80. And I'll give it a name so that I can refer to it more easily. And then the image name, which is whatever you decide to call it. So in my case, six-eyed is a badly chosen handle that I've had for years. When you publish things to Docker Hub, you have to use your handle and then the name of your application. So in this case, it's six-eyed product. I should have used a shorter name. Product launch web v2. v2. Okay, so that v2 tag is interesting because I can put versions onto my images. So I can have lots of versions of my product launch website image on the hub, v2, v3, v4, v5, which I've actually got. And you can tag them with whatever you want. So out of your build process, you could tag it with your commit ID, and you can track everything back down to make sure that you've got several versions of the same application, but they're all stored, and you can run any particular version at any time. Okay, so that's running now. Now I've got my product launch website and my database server running in separate containers. If I want to access that website from on the host, I can use docker inspect and give it my container name to find out some details about that container. And that tells me, among other things, that port 80 is available, and this is the IP address of the container. So this is like a kind of virtual IP address that Docker assigns. So inside the container, let's paste that in. Inside the container, the application thinks it's running on its own server. It's got its own version of Windows, it's got a host name, it's got an IP address, it looks like it's got its own server. When I first hit this, it's going to be setting up, it's going to take a minute or two to spin up because it's setting up all the stuff. This is a completely empty environment. I've got a new SQL Server instance, so when Entity Framework finds that, it's going to create my database, deploy the SQL schema, insert all my seed data and all that sort of stuff. And then I'm also going to wait for my worker process to spin up in the container. So that's up and running now. If I want to see what my container is doing, I can use more Docker commands like docker top on my web application, my web container, and that's going to tell me the processes that are running inside the container. And it tells me how hard they're working. So in this case, I've got the main thing I'm interested in is my W3 worker process, which is using 180 meg of RAM. And there are a few other background services, which is the bare minimum you need to get your Windows app running in a Windows container, and they're using a few megabytes each. So my whole IIS server, my whole web server, is running in about 190 meg of RAM to be able to serve my content. So, and I'll go through and actually use this app this time. So I click on sign up. The app's exactly the same. I haven't changed the code. I'm just running it in the new platform. So I can go through and fill in some details that hopefully are already in my cache. United Kingdom, company name, Docker, and a role. I don't know why I'm putting the read, it doesn't really matter, but hey, those are my real details. Okay, so clicking go runs the code that I showed you earlier, synchronously calls into my database. I don't know what's happened here because I don't see it in any output in the web application. But if I want to find out what's happening in my SQL Server database, I could do the same docker inspect command. Let's run that. Docker inspect SQL Server. And that's got an IP address too, and it's got a port exposed, so I could connect to this SQL Server instance running in a container using SQL Server Management Studio or Visual Studio or any other SQL client, because it just looks like a SQL database, just happens to be running inside a container. But also, I can make use of Docker to run commands inside the container from the host. So if I want to find out some data that's in that container without having to fire up a SQL client, I can run this command, which is too big for me to remember, which is why I'm pasting it in. And what that's going to do, so I've got Docker exec is going to execute a command inside the container called SQL Server. And the command it's going to run is some PowerShell to invoke a SQL query. So that SQL Server Docker image that Microsoft own, as well as having SQL Server installed, it's got all the PowerShell commandlets installed on that image, so I can use those from the outside. This machine doesn't have SQL Server installed. When I said it did earlier, that was a lie. I was using Docker for version 1.2. But the image, the container here, has got invoke SQL command, so I can spin that SQL query in, and I get the output. So that's coming from my SQL Server running in Docker. Okay. So let's go back here. So that's version 2 of the application. So far, all I've done is move my components to Docker. So now I've got, in version 2, I've got 2 images that I'm using. One I haven't had to do anything for. I've just pulled that from the hub because that's Microsoft's. And the other one is my own image that I packaged up my own web application. So at this point, I've already got a whole bunch of advantages. So one of the major advantages I've got is consistency. Anytime I build a new version of my application, the process is exactly the same. If I add new dependencies, or if I change to MVC, or a new version of .NET, or whatever, I'm still going to run the build to generate my published output, and then run Docker build to package it up in an image. I'm going to store it in exactly the same way, because it's all going to go up in my registry. And I run my application in the same way. And it doesn't not only consistent for versions of my app, consistent for different types of application. So the way I started SQL Server was exactly the same as the way I started my web application, just with Docker run. The way I manage it is exactly the same. So if I wanted to see what was running inside my SQL container, I use Docker top. We'll see later on, I can use Docker logs to see what's being written by my application logs. So I manage them all in the same way. It doesn't matter what type of app we've got. And I could stop there, but we've got a bit more time. So I'm going to carry on. I'm going to use this version 2 as my foundation to modernize my application. So the fact that Docker lets me run all these processes in containers that are really lightweight, so I can run lots and lots of applications on my machine, I still have isolation, but Docker provides the plumbing between those containers to talk really cheaply, enables me to add more components in different containers and bring a lot more features into my application. So I can deploy quickly and safely because it's all automated, and I can start breaking up my monolith into different components and have Docker plumb everything together for me. So how do you go about this modernization? Modernization is going to mean different things for different apps and different stakeholders and different enterprises. So you might have, we're not talking about full re-architecture here. So what I like to do is to think of it from the feature level. So feature-driven modernization by enabling more functionality within your application. So there's a few problems with this app that I'm going to address for the rest of the session. The first one is performance. So I make a synchronous connection to SQL Server whenever anyone signs up. And I make 3 calls to the database just when people click on OK. Trouble is, that doesn't scale. So if we're doing a marketing launch and suddenly we have tens of thousands of people hitting our website, that's going to be a bottleneck on my SQL Server. Now, I can easily scale up my web application. I can just have more hosts and run more containers, but I've still got a bottleneck in SQL Server. So the way the application runs at the moment, the web is tightly coupled to the database component, or we need to scale them up together. So we can address that, and we'll see how to address that shortly. Then I've got a data insight problem. So I'm using SQL Server. If anyone from the business wants to actually get some information out, they have to contact IT. So they're not going to run a SQL command. They're not going to have access to the database or any SQL clients. If they want to find out the breakdown of different types of roles from people signing up, they have to put in a support ticket. It's going to sit in a queue for ages because no one wants to do it. And when they do pick it up, they're going to have to write some SQL or put it into an Excel spreadsheet. So it slows everybody down. And the last thing is the UX. So even though I'm running in Docker now, I'm still running a monolith in Docker. If it's an old application, chances are there probably aren't very many automated tests. And the release process, if it's a big application, is going to be an out-of-hours process with a whole chunk of time allocated to smoke testing and user acceptance testing and all that sort of stuff. If the product owner wants to have a new landing page, a new home page, that's a tiny change in terms of development, but all the rest of the cost is still there, even though we're running in Docker, because I still need to. Docker makes it easy for me to build that new version of the home page and to release it, but all the other activities around there are probably still the same. So we're going to address all these things just by leveraging what we can do already with Docker. And the first one we're going to look at is performance. So I've got my web application making synchronous calls to my database. So how do I make that change so I can scale it up? Well, it's page 1 of enterprise integration patterns. What I'm going to do is I'm going to put a message queue in between. So from my web application, when somebody signs up, instead of making a database call, I'm going to publish an event to a queue. And on the other side of the queue, I'm going to have a new component listening for those events, and that component is going to do the database update. So that means I can scale them independently. And if I'm doing a big marketing drive, I can have lots and lots of web containers running, and the queue will fill up, and then the other component will just pull off the messages when it's got time to do them and put them in the database. I don't have an SLA that says, when you click OK, you must be in the database within 30 seconds. So for this particular feature, it doesn't work like that. It could take a minute or 5 minutes. It doesn't matter how big the queue gets, because we might not send out an email for a week. OK, so let's see how this looks. So let's go back to my SQL server, So say you're going to see this several times. Check out version 3, where my code is. Oh, that's V3. The V doesn't work properly on my laptop, which is difficult when you're trying to do this. So V3. Not that I'm saying anything wrong with Dell, by the way. So switch to v3. I'm going to reset to get rid of the containers from version 2. And then we'll have a look at what's changed in the application. So Visual Studio knows something's changed because I have changed code in this version of the app, because I've moved the way I've changed the way my feature works. So we'll have a look at what's changed. In my web application, in the sign-up page, it's all the same boring boilerplate stuff until I get to line 70 when you submit the form. I create my prospect object in the same way, but instead of talking to the database and making a call, I build up an event object, a prospect signed up event, which then contains the prospect details that I've got off the form, and I publish it to the message queue. So that message queue is in a new project, and the message queue is just a little helper that abstracts away dealing with the particular message queue. So in this case, I can publish a message of a particular type, and the only message type that I've got defined is this prospect signed up event. So this message is just going to contain my prospect, contains the date timestamp from when they signed up, and it's got a subject, like a subject matter, so that people who are listening to messages know that this is a sign-up event. So it's all pretty simple stuff. So on the other side of the message queue, I've got a new component, which is just a simple .NET console application. So this console application, when it starts, is going to use the same messaging library to create a connection to the message queue, to subscribe to my signed-up event, and then it's going to sit there and listen. So this will run indefinitely. It's going to sit there and wait for messages to come in on the queue. When it gets a message, it writes some log entries, it pulls the prospect out of the message, and then this is the exact same code from version 1 to create my prospect in the database. So what I've effectively done is taken some features, some functionality from my web application, put it in a different component, and I'm using a message queue to connect the two together. So if this was a way more complicated function that did all sorts of validation and stuff, the process would be the same. I take it out of my web application, I put it in a different component, and I join them together using what I can do with Docker. Okay, the only other thing that's changed is in my web config, I've taken out the connection string. So as I said, you can run any app in Docker. Docker doesn't mandate how you do configuration or anything like that. But Docker integrates better with some types of approach than others. So Docker doesn't know anything about web config and config management that's in .NET. But it does know about environment variables. And all the frameworks support environment variables, and most of the platforms support them. So what I've done is I've taken my config out of web config, and I've put it into environment variables. So in my model for the database for Entity Framework, I'm using a custom database connection string that I pull from the environment variable, which I can set using Docker, and exactly the same for the message queue. The message queue's got a custom config class that's expecting to find an environment variable called message queue URL, which tells it the location of the message queue. So that's all that's changed. So let's go and build this, and then we'll have a look at what we're building. Okay, so in the Docker world now, my web application Docker file is more or less the same. It's the same up to point where at line 12 where I expose the port. I'm adding a default value for this message queue URL, a default environment variable value. I can default that because I'm going to own starting up all the containers, so I can be sure that I'll start a container called message queue, so I can use a default value for that. Nice and simple. The other stuff hasn't changed. What I've also done is I've added a health check. So the health check is a really neat part of Docker. Because Docker doesn't understand my application, it doesn't know what's running, it doesn't really care what's happening inside there. All it can do is watch the process it started and be alerted if that process goes down. The health check feature lets me go one step further and tell Docker how to check my application is still healthy. Because I could still have IIS running, but it might be returning 403s all the time. So what I can do here is give it a really simple little script, which in this case, this is going to run inside the container. It's going to make a little PowerShell call to the local host, which is the web app running in the container. If I get a 200 response, I tell Docker everything's OK. And if I don't, then I tell Docker there's a problem. Docker will run this by default in the container every 30 seconds. So not only can I use this to check my application's healthy, I can also use this as a smoke test. I don't need to manually smoke test my app because Docker will do it for me, as long as my script is testing enough of the app for me to be confident. And it's also a warm-up, because it's going to periodically keep my app pinged with a request. It's going to keep it alive. If I've got a cache that's got some timed expiry, then this is going to keep my cache up to date for me. I've got a new Docker file for my second component, my message handler, which is just my .NET console app. This is much simpler because I need fewer components to get my app up and running. It starts in the same way. I start from Windows Server Core, I switch to PowerShell, turn off the DNS cache. So all .NET apps can start in the same way. I don't need to install .NET Framework because the Windows Server Core image has already got 4.6 set up. So all I do is copy in my built project, set the same default value for my message queue, and then I tell Docker, when you start the application, just start my console app. That's all I need to do. So let's start this up and running. And I'm starting it in a different way, which I'll explain right now. So I've now got a distributed application across multiple components. I've got my database, I've got my web app, I've got my message queue, I've got my message handler. They're all running in different containers. They need to run under the right names to make sure they can find each other. They need to run in the same Docker network. They need to be started up in the right order. I could do Docker run manually and start them all up in the right order, or I could write a PowerShell script to do that for me. But there's another part of the Docker platform called Docker Compose, which lets me compose a distributed application and specify what needs to go into starting that application up. So just like my Docker file is effectively replacing my deployment document for a single component, my Docker Compose file is effectively the deployment document for the whole distributed solution. So it's written in YAML, so it's fairly easy to read. And what it does is it just takes the place of all the Docker run commands. And you can use the same sort of values that you would pass to Docker run. So my database is my product launch DB. I'm starting it from Microsoft SQL Server Express image. I expose the port, I set the values for the environment that I need, and I connect it to a specific network. The message queue, that's my new component. I'm using NATS, which is an open source message queue. It's on Docker Hub. I'm not building that myself. I'm going to pull it down from Docker Hub. I've got my product launch website, which is version 3 that I've just built from my own Docker image. I specify the ports to expose. I've got my database connection string in here as an environment variable. Got the password in there. Like I said, that's not great. There are better ways to do it. I won't have time to show you. I can also tell Docker Compose that this service, my web application, depends on other services that are running. So that dependency is going to let Docker Compose start them up in the right order. It won't start my web application until my SQL Server is up and running and my message queue. And my new component is my message handler. So again, that's been built from my image, from my application, packaging my .NET console app. I also give it the database connection string, and it also depends on the database and the message queue. They're all plugged into the same Docker network, so all these containers can access each other by the host name, and then the DNS inside Docker will get them all up and running. So the way I started that was with Docker Compose up, which is just going to run through my Docker Compose file and start all the services in the right order. The reason I've got an error there is because I've got a few beta bits and pieces, and sometimes the networking piece in Windows isn't quite up to scratch yet. We're expecting an update for that shortly. So what it does is it creates all my services, and then I can work with them in the same way. So it's a different way of firing up my application. It's a different way of defining how the distributed solution fits together. But when they're running, they're just running as Docker containers. So Docker PS, I've got 4 containers now: database, website, message queue, message handler, and I can work with them all in the same way. So as before, I can use Docker inspect to get the IP address. Oh, if I give it a name. Of my web application. It's a new IP address because it's a new container. My SQL Server database is a new container too, so it'll be empty. The previous data that I put in there would have been lost because I didn't start my container in such a way that it saved the data elsewhere. You can obviously do that, but I'm just showing you here that if I take my container away, the data goes with it unless I've specifically run it to have the data outside of the container. So I've got my IP address for my web application. So this is version 3. And I can spin up to that. So there was no startup time here because I was gabbling for long enough that the health check kicked in. So Docker ran that health check for me. It hit the home page for my application, which hit my entity framework, which set up my database for me. So that ran within 30 seconds. I knew as long as I talked long enough, there wouldn't be a delay when I started the application. So now I can sign up. I'll put in a different Docker employee. Let's sort that out. And we'll save that and we'll see how it looks. So from the user experience, it's exactly the same. It's the same website. When I click go, I get a thank you page really quickly. The difference is, if there were tens of thousands of people doing the same thing, I'd still get a thank you page quickly. With the previous version, because I'm making that synchronous connection to SQL Server, I'd be sitting and waiting, and I'd probably get a timeout page. So that's run now, so that's cool. So we can see what's going on in our database by using the same command. I can use that same select command inside Docker to see what's the data that's in there. I'm only going to have one row because this is a new container. But I can also see what's going on in the other containers. So if I do a docker ps to list them all out, I can refer to a container by its name or by its ID. If I want to see what my message handler has been doing, I can run docker logs with my message handler ID, and this is the output from console.writeline. So Docker can see what's being written by the application to the console, and it can surface those logs. And it can actually, the logging part of the platform is really extensible, so I could send those logs somewhere central and do all sorts of cool stuff. So when the application starts, it listens for this particular event, and it tells me that it's received a message from when I clicked sign up. It's saved the new prospect, and I've got my prospect ID in there. So I can see what's happening by looking at the logs for this application. So this is a .NET console app. I've also got an ASP.NET app that I can treat in the same way. My message queue is a Go application. So my message queue is called Docker message queue 1. Let's clear the screen. If I look at what's happening in there, I can see the process is running. And again, it's all behaving in exactly the same way from Docker's point of view. Docker doesn't know this is a Go app. It doesn't know my other apps are .NET apps. It doesn't care. It's running a process. It will keep an eye on that process and make sure it's up and running for me. The actual process is this gnats-d, which is the Go application that's running my message queue. It's using 2.5 megabytes of memory. So that's an incredibly lightweight message queue. It's got a huge amount of capability. I didn't have to do anything to get that into my application. I didn't have to download an MSI or run it or set up some configuration. It's just there on the hub, ready to plug into my solution. OK, so that is version 3. Cool. So we fixed our performance issue, because now I can scale independently. I've decoupled my web application from my database application. My web application for this feature is effectively stateless now, so I can run lots and lots of my web containers, and they're all going to write to my message queue. And if it takes a long time to pull all the messages out and save the data, it doesn't really matter. For this particular feature, we're now using an event-driven architecture, because we're publishing events to a queue that other things can listen for. But I didn't re-architect the whole solution. I've just taken one feature that needed to be fixed, and I've used the Docker platform to make that change really, really easily. The message queue I'm using called NATS. It's open source, cross-platform message queue. It's incredibly capable. It'll do tens of thousands of messages per second easily. It clusters, so I can have lots of queues, lots of queue containers running on my hosts to get reliability and scalability. And it's free to use, and it's up there on the hub, so you just plug it straight in. OK, so that's our first one. That's a tick for our first feature. We've just added a really high-performing message queue that's available on the Docker Hub that someone else has put there for me, put it into my solution, and then broken out one component into another container so that I get the scalability from the decoupling. But I've still got a problem if I want to see any of that data. So in my case, I'm using the Docker command to run some SQL. For the users, obviously, that's not an option. They're still going to have to put in a ticket to get some data out. So we're going to address that next in version 4. How are we going to do that? Same approach. I'm going to take some existing tried and trusted tools that are on Docker Hub, bring them into my solution, and because I've now got an event-driven architecture for the event I'm interested in, I can just hook into that. So I'm going to add a new component which listens for the same event and publishes the information to a different data store, to a reporting database that the users can access themselves. OK, so same process as before. Let's clear this down. I'm going to check out version 4 of my application. And in Visual Studio, let's reload this. I haven't changed anything to do with the original application from the previous version. So everything is the same for my web application, for my original message handler that's saving to SQL Server. None of that changes. I've added a new component, which is another .NET Console application, which looks exactly the same as the previous one. When the app starts, it connects to the message queue. It listens for the same event, the prospect signed up event, and then when it gets an event, it saves it in a different type of data store. So I'm using a document database. I'm going to be using Elasticsearch, which is a massively popular open source document database. The only thing that's changed is how I build the representation for my new data store. So I'm getting the same information. I'm creating it as a document in Elasticsearch instead of creating it in SQL Server. So this component is going to be added to my solution now. So I'll go ahead and build it. And then we'll look at how it looks in Docker. So for the web application, Docker file hasn't changed. For the original prospect handler that's saving in SQL Server, that hasn't changed. I've got a new component, a new Docker file for my index handler, which looks exactly the same. So when you start writing these Docker files for your components, actually great chunks of it are going to be the same for every type of app that you write. You've got the flexibility to configure each component exactly as you want to, but there's going to be a lot of commonality. So Windows Server Core, PowerShell, turn off the DNS cache, standard. Copy in my new .NET Console app, set some environment variables. Again, I can be confident about this. It looks like it's a nasty hard-coded string, but because the platform is going to make sure that everything starts up how I want it to, I can afford to hard-code these things. So when I run this, I don't need to understand how it connects to other components because that's built into the image. So a default value for the message queue, so I can listen for these events, and a default value for where I'm going to find Elasticsearch. When I start, I run my startup command. Okay, so let's clear this and get it running. So this Docker compose up is just going to start my containers, and D is that same D flag to put everything in the background. Okay, so that's my new component. The build process, well, it's the same stuff. I've just added another project to build. So I build my website, build my original handler, my new handler, and then I've got 3 Docker build commands, one for each image. So I've got an image for my web application, an image for my save handler, an image for my index handler. And my Docker Compose file now is much bigger because I'm adding various new components to enable this feature, this data insight feature. I've got my database, I've got my message queue, I've got Elasticsearch now. So Elasticsearch is coming from Docker Hub. I'm not building that myself here. I don't have a Docker file for that. Someone else has got the Docker file for that, and that's coming from the hub. And Kibana is like a self-service UI on top of Elasticsearch. And again, that's coming from the hub, and it knows about the Elasticsearch image, so those two things are going to work together really nicely without me having to do anything. All I do is expose the port that it runs on and say that this service, the Kibana service, depends on the Elasticsearch service. It's all nice and straightforward. Well, web application, that hasn't changed except that I'm using v4. So I don't actually need to rebuild this application to add this new feature. And whether or not you rebuild and tag everything with the same version is a choice that you make. So I could be running version 3 of this application, but I've chosen to keep everything in step. So I know when I need version 4, I just run version 4 of all the components. Prospect handler the same for SQL Server, and my new index handler that depends on the message queue and on Elasticsearch. I don't need to specify where to find Elasticsearch because that's built into the image. As long as there's a container called Elasticsearch, this thing just works. So I don't need to specify the details of that. So if we look at what Docker Compose has done, it's reusing some of those components. So it knows, since I last ran Docker Compose, that the message queue and the database are up to date. They haven't changed. Because I'm using new versions, I'm getting a new version of my website and my handler. I've got completely new containers for Elasticsearch, Kibana, and for the new handler. So I can do like an incremental release with Docker Compose. And it will look at what's currently running, it'll compare it to the definition of the solution in the compose file, and it will basically do the diff. So it will run new things if it needs to, it'll recreate them if it needs to, and it will start new things if they're new components. But just like before, let's have a look at what's running. So I've got a whole bunch of containers running now. I'm still not using hardly any of the resources that are on my machine. I could run tens or dozens of containers, and they would all work happily. But I can work with these things in the same way. So my Docker website is now, get the IP address for that. Oh. And there's my IP address. And I can use that to go to my website and put some data in, same as before. So it's exactly the same. It's already warmed up because of the health check that's in there. I could go and sign up and put some more data in. I'm not going to do that at the moment. I'm instead going to have a look at some of these other things that are running in Docker now. So I've got Elasticsearch running. I can have a look and see what's going on in my Elasticsearch container, and I can see the logs that are written by the process. This is a Java application. I don't have Java on my machine. Why would I install Java on my machine? This is running inside the container. It's with the right version of Java. It's all configured. It's just straight down from the hub. It just gets used. If you run this for yourself for the first time, it will download these new images. So if I hadn't already pre-prepared this, it would take a few moments to download that Elasticsearch image. If I look at what's going on in Kibana, which, as it happens, is a Node.js application, and I can see the logs of Kibana starting up and getting started. Node.js, don't have that installed on this machine. It's fine. It's all configured inside the image. So when I run my container, it's got everything it needs to spin up the application. Now, I said I wasn't going to put in my form. And the reason I'm not going to do that is because I've got an end-to-end test in here, which is going to pre-populate some data for me. So I've got a spec flow test that just needs the URL, or the host name, or the host rather, which if I'd actually saved it, that would be useful. Okay. And this sort of end-to-end test that's going to flex from the entry point is really useful if you're doing this sort of modernization by feature approach. So in this case, I'm just using this test to drive some data. But I could have assertions in here that make sure my data gets saved to SQL Server, and my data gets saved to Elasticsearch. And if I change the setup of my application and change where these components live, the end-to-end test should still run. So when I submit my form, if I had a check to see that the data was in SQL Server, that check is still valid, even though I've moved the components apart. So this sort of automated testing, which this is just a basic example, is really good to have in your solution if you're looking at breaking it apart and moving features around. So I'm going to let that run on. And while that's going, I'm going to have a look at my Kibana. So Kibana is this, again, it's an open source tool. If I didn't know anything about it, when I run it, I know that it's on port 5601 because it tells me here. So I can go back to my original web application and browse to Kibana. And this is straight out of the box. I'm not doing anything to set this up. It's found Elasticsearch because it expected to find it on a container called Elasticsearch, and that's up and running. The only thing I need to do is tell it the name of my document collection, which happens to be prospects. And it will connect to Elasticsearch, and it finds all the data that's in my prospects collection. There's already some data there because my test had put it in, so I can see all the fields that Elasticsearch knows about. So Kibana is really cool because I can look at the Discover tab, and it's just going to show me all the data that's in there, with a timeline showing me when these documents got created. So from my really basic tests, I can see each individual prospect that signed up, and I can see all the data that they put in. So if I wanted to, I could get a list of email addresses and that sort of stuff. But for power users, it's really easy to pick up their own requirements and implement it with Kibana. So if I want a pie chart from my prospects, I can split it by the terms in the role name field, and I get my nice pie chart that's showing me, with my test data, 50% of people are decision makers and 30% are architects. If I want to change to look at countries, I just change the field and run it again. So this is self-service analytics. This is a really easy application to use. I can give this to power users. I can secure the container, so I can only access Kibana from within my network. So that wouldn't be publicly available, whereas the rest of the website would. And not only can people go in and build their own visualizations, but I can build dashboards and have lots of visualizations and give you a central point to find out what's going on, and users can build those themselves. So I've added a huge amount of capability here. We're doing very little work, which is what we all want to do, I guess. So that's version 4. I've added self-service analytics by doing exactly the same that I did with the previous versions. I've added some new containers. One of them has got some of my code in it, tiny amount of code to create my document data. And I've plugged in components that are available on Docker Hub. Now, I could do this release during office hours while people are using the app, because I don't need to change the existing components. In this case, I did, because I tagged them with the new version. But I could just release these new components that are hooking into my original event-driven feature, and I wouldn't have any downtime at all for this. So not only can I do a really nice, safe update, I've got some fantastic capabilities here. The two things that I've plugged in, Elasticsearch and Kibana, they're enterprise-grade components. They happen to be open source. But Elasticsearch, you can run it in Docker. You can run clustered clustered Elasticsearch instances on different containers on different hosts. And I've had this running in Docker with terabytes of data, and it just all works. You don't need to understand what it's doing. It's like on version 5 of the product. It's tried, it's trusted. People use it all over the world. We just plugged it into our solution without having to do hardly anything. OK, now we've got our data insight, so people, business users can go and find out who's signing up for our great new product launch, which leaves us with one last feature to do, which is the UX. So I want to be able to change the landing page without having to do a full release. So let's go and have a look at how we're going to do that. The approach is going to be exactly the same. I'm going to have a new component just for my home page, and I'm going to change my original web app so that it hooks into my new component. And let's see this. So exactly the same as before. I'm going to check out version 5, so I don't have to try and write any code and spell everything wrong, and get that building. So version 5, yes, I want to reload. The only thing that's changed is the content of my default page from my web application. So what I do now is when I hit the default page, I check to see if there's a configured homepage URL, which will be an environment variable. I'm using that like a feature switch. So if there is a homepage URL configured, then instead of rendering my own content, I'm going to get the content from that URL and render it back out. So this is a way to pass control over to another component, but I've still got the same entry point. My web application is still where people hit, and now it's kind of devolving control out to a separate component for my homepage. And in the Docker world, the only real change is a new Docker file for my homepage component. So this is using Windows Server Core, switch to PowerShell, turn off the DNS cache. It's a web application, so I'm installing IIS, but it's not ASP.NET. I'm using a different framework, so I'm just copying in my HTML document, and I've got a health check in there to keep it all up and running. So let's see, that's all built. So I'll do docker compose up again to start up the new versions. And in my docker compose file, I've got a new component for my home page, which is using my new version of my homepage image that I've just built. And I've changed my product launch website to include that homepage URL, that configuration value, which I'm also using like a feature flag. So that's all up and running now. So if I do a docker ps, I've now got a pretty distributed solution. I've got 8 containers that are all doing different things, but my entry point for my app is still exactly the same. And for users, the way they use it hasn't changed either. So let's have a look at this web application now. So let's inspect that. Oh. So this is a new container because I've changed the image definition to switch to version 5. And when I browse to this now, we'll see my awesome new web page. Hey! So like, this is like totally futuristic design. Sorry, I'm not available for design consultancy. But the point is, this is not ASP.NET. I'm using the marquee element from HTML. But I could be using anything in there. And if I want to change my homepage, if for some reason this wasn't popular, then I could switch just the homepage component to a totally different stack, and I wouldn't have to change my running application. When this stops blinking, if you can click it, I just go back into the previous page, and I can put any old data in here, v5, 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 click on Go, and that's going to go through the rest of the stack. And because I didn't change my other components, I'm still using the same Elasticsearch, the same Kibana. My new data that's just gone in there is already indexed in Kibana. So there's my version 5 data that I've just put in. So that's all up and running. So that was version 5. That was pretty quick. And this is our full solution now. So this is a fairly elaborate, complex solution that's been built up in stages with a feature-driven approach. And the final thing I did was to swap out the homepage for to show off my awesome design skills. I could be using React or Ember or whatever I want to use. So this is good for, not only is it good for the product owners who can change UI without having to do a full release, it's great for architects or devs who want to try out a new framework in a controlled way. So I'm only going to build the homepage. I've only got to test the homepage. When I release it, everything else will work. And the interesting option is I could use a CMS in there. So I could use Umbraco, open source content management system. I can let users do their own content. OK. So I've done that too. That's 3 ticks. That's great. So let's remember we started with a web forms app and a SQL Server database. And now I've got an event-driven architecture, self-service analytics, potentially self-service content. So that's a massive step forward with very little development and very little risk when I did my new applications. So your takeaways, Docker is a mature platform. I've shown the key features. You've probably got a lot of questions about persistence and security and scalability. They've all been answered because Docker is being used in production in some significant applications, significant clients. You can move your app to Docker easily. You can take your existing app and run it in Docker. As long as you can install it and run it without a UI, then it'll run in Docker. And then the slogan, when you've Dockerized it, that enables you to modernize your application. So sounds a bit like a cat poster. So there's your cat poster. There are a few more talks today about Docker. So in room 2 next, Ben Hall's going to talk about how Windows containers actually work. Philip's talking about monitoring later on. And then Michelle's talking about orchestration, which is how you make all these different components work together. A few search terms for you. We've got some labs on GitHub that you can follow through to test this out for yourself. Captains are the equivalent of Microsoft MVPs. And our big conference is DockerCon. I'm tweeting all the time about this stuff. I'm just Elton Stoneman at Twitter. That's it. So I hope that was useful. I'm around all day. I've got some swag if you want it. Ask me any questions you've got. And enjoy the rest of NDC.